This video will demonstrate how we can add and modify custom datasets within DI Viewer. The log that is shown on the screen is an MIHPT log that is displaying electrical connectivity in the far left, HPT injection pressure, and then our three detectors, the photoionization detector, halogen specific detector, and the flame ionization detector. Since both the PID and XSD are responding, it's a halogenated compound, likely a double bonded because the PID is showing up as well. So on this particular site, we actually did take samples before and after and throughout the contaminant zone. What we're going to do is add some custom data sets from the lab data, and I'm going to show you how to do that. So the first step to adding custom data sets is to come up to the Tools tab at the top left corner. You're going to left click on the Tools tab and left click on Custom Data Sets. We need to select the log that we want to add that to. If you just have a couple samples to add to the log, you can just type in your data type, your concentration units, and then either depth in feet or meters, whichever is appropriate. I'm going to type it in the depth, the meters auto enters, and then we'll type in our concentration and for TCE. You can do that for a couple depths, 2, 3, whatever, add that in and hit done. To display the custom data set, we're going to right click on the graph, go to secondary series, and display TCE. Since this was made up data, we're going to come back and delete that custom data set and enter a new one. So we're going to go to our file, we're going to come down and delete this, and then we're going to add another custom data set. This time it's going to be from a spreadsheet of the actual data that was collected from the site. So it's XVOCs, microgram per liter. Now we're going to go to the spreadsheet of the lab data that we collected from this particular sample. These are all the depth screened intervals that the groundwater sample is taken from. Here's the total VOCs, which is our PCE and daughter products summed up. The screen interval, I actually put a point, which is the center of the screen. We want to have a specific point, and then the total VOCs. So I'm going to highlight those, right click, and copy, and then we're going to go over to our custom data set and enter that in. Since those are in meters, I'm going to highlight the depth in meters and then select Control V, and that will input the data into there. Your depth in feet will auto enter. With our lab data entered in the custom table, we're now going to select OK and Done, and we're going to come over to our XSD graph, right click on it, secondary series and XVOCs, and now our data is displayed. Total VOCs, the data points and line linking all those together. I'm going to change the display of our custom data set though. First I'm going to go to the metric mode, display our depth in meters because that's what our samples were taken in. I'm going to right click on a data point and go to graph properties. I'm going to uncheck the line being visible. We're going to now come up and display our samples in bars, which will correlate to the width of the sample screen that the groundwater samples were taken. We're going to write this as 0.3 meters, which was the length of the screen that was exposed. The sample points were in the center of the screen, but if they're in either the beginning or the end, you can select that, and you'll see how that'll shift the bars to display properly the interval that you want. You can of course increase your transparency and select OK, so it's another way of displaying the data. Another way that custom data sets have been used is we've seen geologists come up with a numbering scheme for specific soil types based upon visual observation of the soil that can be entered into the software to then correlate the electrical connectivity and HPT pressure to those displayed soil types. So this is the process you'll go through for entering custom data sets, whether it's actual lab data, soil or groundwater samples, or from some other purpose.